Hello, my friends. I have something a little bit spicy, I suspect, for you today for a couple of reasons. One reason is that this gas is pretty much as fresh as gas can possibly get. Things worked out kind of luckily with the timing, and Philip literally just posted this for testing last night right before I went to bed, and I have not gotten a chance to check it out until just now, and I've decided to kind of fly by the seat of my pants and do the recording live. So this is a blind solve. I have not ever seen this puzzle before. If I don't do it justice, you'll never see this video, so if you're hearing this right now, that means it went pretty well. Next, this is an X-sum Sudoku, and X-sums is one that we've done in gas before, but I don't think we've actually explained it at any point on this YouTube channel. And it's a variant that doesn't come intuitively to a lot of folks. I know that the first time I ever saw it, I was absolutely baffled by it, so I'm going to try to give the gentlest possible explanation of the rules here before I get started. So first of all, we do have normal Sudoku rules today. So we're placing the digits 1 through 9 in each row, each column, and each 3x3 region. And then on top of that, we have these numerical clues outside of the grid. So some rows and columns have numbers adjacent to them. They can be above, below, to the left, or to the right. Every time you see one of these clues, you are going to look at the digit that is right next to it in the grid, so the digit that is nearest to the clue. And we're going to call that digit X. And now X can be anything, depending on what the clue is. And now the way this works is that you're going to take X, and whatever X is, like say X is 3, if it's 3, you're going to take the sum of the first 3 digits in that row or column, including X itself. So we're going to take the sum of these 3 digits. And that has to equal our clue total. So that would have to equal 9. And it's not limited to just being 3, for instance. This could be a 2 if there wasn't a 7 down here. And then we would take the sum of the first 2 digits, and that would have to equal 9. So that would make that a 7, which of course is broken. But if it wasn't, that would also be a possibility. Or for 12, we could say if this X value was a 3, then the first 3 digits down here at the bottom, because we always start from the direction of the clue, those would have to sum to 12. So for example, those could be 1 and 8, or those could be 4 and 5. Or if this first X number was a 4, then these 4 digits would have to sum to 12. They'd have to be 1, 2, 4, and 5 in some order. And that, by the way, is not something that should have been incredibly obvious. I only have that top of mind because I've solved a lot of X sums. I was not comfortable with them at first. I kind of became comfortable with them with time. And now, to be honest, they are one of my very favorite variants. So hopefully I can show you guys some of the magic in this Philip Newman puzzle. It doesn't even have a title yet. That's how fresh this is. So, how are we going to make a 3? Well, we definitely can't have X equal 1, because that would just give us a sum of 1. We'd only be summing 1 digit. So if X is 2, we're summing the first 2 digits to make 3, which would make that 2 and 1. And in fact, every single time you see a 3 clue in an X sums puzzle, that is always a 2 and then a 1. If we made that a 3, we'd be summing the first 3 digits. That would definitely end up being way bigger than 3. So let's look at some of our other small numbers, because we're going to start to limit them as we place X digits. For instance, how are we going to make 8? We could make 8 as a sum of 2 numbers, but that would conflict with this cell. So we're going to have to make 8 as a sum of 3 numbers. 8 is definitely too small to make it as a sum of 4 numbers, even if that 9 wasn't there. So how do we do 8 as a sum of 3 numbers? Well, we start with a 3, and then we need a total of 8 minus 3, which is 5 remaining. Well, how do we make 5? It's either got to be 2 and 3, which doesn't work because we'd be duplicating the 3, or it's got to be 1 and 4, which it is. Now let's look at some of the other small numbers, and generally small numbers are the place to start with X sums, by the way. So how do we make a 5? We can't do a 3 because the smallest number we can make with 3 cells is 6. 5 is a little too small. So that's going to have to be a 2, and then to bring us up to a total of 5, we'll have to include a 3. 7 is kind of an interesting one. This is an old friend for folks who are really familiar with this variant, because you would think that you would be able to start it with an X value of 3, right? Because 7 is big enough that you can make it in 3 cells. But the trick is that if you start this with 3, we've actually broken it, because we can't make a sum of 3 digits that add up to 7 that has a 3 in it. Once you've used 3, you still have a total of 4 left to go, and the only way to make 4 in 2 cells is 1 and 3, or by duplicating the 3, so that doesn't work. And that implies, which I think is really cute and kind of interesting, it's why you see a lot of 7s in XSums, that implies that 7 is always 2, 5. How about the 6th clue? This is a small number too. We can make 6 and 2, we can go 2, 4, or we could make 6 and 3 still. We could go 3 and then 1 and 2 there, and we don't know which yet, so we're going to have to leave that on the table. How about 11? We could do 11 and 2, 2 and 9, but that's broken for a few different reasons. We could do 11 and 3. Could we do 11 and 4? Well, it's the same story as with this 7, where even though 11 is big enough to do a sum in 4 digits that makes 11, we can't do it if we have to include a 4 in there, because the only way to make 11 in 4 digits is 1, 2, 3, 5 with no 4. So 4 is not a valid x value here. It's got to be a 3. And then these 2 digits will sum to the remaining total, which is 11 minus 3, which is 8. So those are going to be 1 and 7, or possibly 2 and 6. We do not know which yet. 9's pretty small too. This is going to have to start with a 3, because we can't start it with a 2 for several reasons. I think one of those I included in the rules explanation by accident. So this total has to be 6, 9 minus 3. Can't be 1 plus 5, so it must be 2 plus 4. 13, we can't start it with a 2, that's too small. We can't start it with a 3 because we've already used the 3. We can't start it with a 5 for a couple of reasons, one of them being there's a 5 in the row already. The other one is that we can't make 13 in 5 digits, too small. So this has to start with a 4. So that means to sum to 13, we're counting these 4 digits, right? So we already have a total of 4 plus 1, which is 5. We need these guys to total to the remainder, 13 minus 5, which is 8. So how do we make these guys sum to 8? We can't do 1 and 7, can't do 2 and 6, we gotta do 3 and 5. Awesome. I'm noticing now that there's only one position left for 2 in this column, so I'm gonna go ahead and place that real quick. Can't go here, here, or here, so there is my 2 in the column. Let's do some more of our XSums clues right now though. So this could start with a 2, because this could be 2 and 8. It could also start with a 3. It could be, for instance, 3, 1, and 6. It could be 3, 2, and 5. And that seems pretty open to me so far, so I'm gonna just kind of leave that on the table for now. How about this 12? Can't start with a 2, that's too small. Can't start with a 3 because we've used 3 already. 5 is too big and it's already there in the row, so this has got to be a 4. How do we make 12 in 4 cells with a 4 in it? That's the same as asking how do we make 8, which is the remainder, in 3 cells without a 4 in it. Well, there are 2 ways to make 8 in 3 cells. One of them has a 4 in it, so that one's off the table, 1, 3, 4. The other one is 1, 2, 5, and that's exactly what we're going to do here. Now there's only one position for 3 in this column, classic Phillips symmetry with this deduction over here, so 3 has to go there. And in fact, I'm going to go a step further and pencil mark these guys. So these have to be 6, 7, and 8. And these are going to be 6, 8, and 9, and I can reduce those a little bit, but not a ton. So what are we going to do next then? Oh, that's not a 5, okay. And I'm wondering, so yeah, the next move is going to have to do with this 6, so we can no longer have this as a 2 now that we've placed the 4 here, because that would place 2 4s in the region. So this needs to be a 3, with a 1, 2 pair to total 6. That makes this a 5, and that makes this a 2 and a 1. The 2 here gives us an 8. And now once we clean up a little bit, we should be at the point of only needing to use Sudoku rules. So that's always a turning point in any puzzle, and I think we might be there. So this can't be 1 or 2, so to sum to 8, this can't be 6 or 7. How about we look at these rows a little bit? So where are we going to put 3 here? It's got to go there. Where are we going to put 2 here? It has to go there, and we need to place 8 in row 4, which needs to go there. And the last 2 digits there will be 5 and 6, and then the last 2 digits here will be 4 and 9. So where do we place 4 in this region? It can only go there. And we're going to place 5 and 6 into these cells, and 7 and 8 into these cells. These last 2 have to be 1 and 6, which will go into those 2 positions in some as of yet unknown order. Next thing I see, there's a 3 in this region down here in the bottom left. It can only go there, so these have to be 1, 4, and 9. Now what does that leave me with? I can't place a 5 in those cells, and I need a 5 in the column somewhere, so that takes care of that. There was another way to see that. I apologize if you saw that faster than I did. Actually, who am I kidding? I don't apologize. We all see things at different rates. I'm not sorry. I am glad that you saw that faster than me, if indeed you did. So what else can we put here? These need to be 4, 5, 6, and 9. Those can't be 6 or 9 because of the 6, 8, 9 triple there. That can't be a 4 or 5. And I don't think that quite resolves yet. Those are going to be 6, 8, and 9. What else have we got? So that has to contain a 1, 6, and 9, and that cannot be a 1. I feel like it's going to be pressure on this row that takes care of this for us. Oh no, it's actually not. I see what I need to do here. So where do I place 2 in this bottom center region? It can only go there, which makes this a 2, 6 pair and resolves all of this really elegantly. These are now going to be 7 and 8. These are going to be 1, 6, and 9. These digits have to be 4, 7, and 8. That's not a 6, that's not a 9, so it is a 4. And at this point, we are definitely rolling with Sudoku. So that's an 8, a 6, and that can't be an 8, so it's a 7. And we can clean everything up down here in the bottom. It's a 4 and a 9, 5 and 6 because of the 6 in that column. That's now a 4. These are 1, 5, and 7, and the 1 and 5 in the row take care of that. There's an 8 and a 7, and that's no longer an 8. And what is next? Come on, Clover. You'll see it. There we go. This is not going to be a 9 because of the 9 in the row. There's 7, 8, 6, 7, and 8. And let's finish off with just a couple of digits in the top center of the puzzle. And that is how you solve Philip's as of yet untitled X sums puzzle. Hope you enjoyed that. Hope it made X sums maybe a little bit less intimidating if you weren't a fan to start with. It's been my pleasure to solve this with you, and I hope you have a good rest of your day. I'll see you next time.